The planet Mars and the planet Earth share a number of critical features that are large-scale electric features. This video is designed to explore some of them and to explore their implications. While Mars is a relatively small planet in comparison with the Earth, at roughly half the diameter of the Earth and 1/10 of its mass, the shared features are surprisingly large on Mars, up to 10 times larger in some respects. That's a paradox, isn't it? It opens up some rather interesting questions for exploration. One of the shared features that is dramatically smaller on Earth, surprisingly, is the Grand Canyon in Arizona. It is hard to imagine that this gigantic carved landscape is small in comparison. It takes a huge leap of the imagination for one to regard this as small. And beyond this, it takes an equal leap in faith to regard this gigantic canyon, with sharply dropping edges, in a nearly flat landscape, to have resulted from water erosion. Where is the enormous volume of material that was supposedly washed away by the erosion process? The enormous sedimentary deposits that should have formed at the river's outflow into the ocean do not exist. An equally critical fact against the water erosion theory is the fact that the water that eroded the canyon out of the bedrock would have had to flow over the top of a major mountain range. Water doesn't flow uphill, doesn't it? It is assumed, in order to save the theory, that the land became elevated after the canyon was formed. That's the only option available to make the water erosion theory seem plausible. It is far more likely that the entire canyon was electrically carved by plasma discharge currents between the Earth and the Sun under the intense electric stress pressure of interplanetary discharge currents, a type of large-scale lightning. The rocks of the Earth, or of Mars, as the case may be, fracture into sand that becomes electrically fractured, lifted off the ground, which then becomes redeposited nearby, as for example across the Nevada Great Basin, in the north of it. The entire Grand Canyon was likely created in this manner, all 446 kilometers of it, up to 29 kilometers wide in some places, and up to 6,000 feet deep. It was likely carved out of the ground in about 10 minutes, with the force of electric stress fracturing while the Earth rotated beneath the electric connection that was evidently linked to the Sun, where the big electric power concentration is located in our solar system. The Sun is 713 times greater in mass than all the planets combined. In the solar system, when the Sun is active, an enormous volume of plasma is concentrated around the Sun. The Earth is rather puny in comparison, so that it would actually be surprising if large-scale discharge events, large in our sense, would not have occurred during the hot times of extreme electric intensity. We have seen some really hot times in the recent geologic history, like 300 million years ago and 100 million years ago. The Grand Canyon might also have been carved out during one of the lesser peaks of high-intensity solar conditions. The Grand Canyon features that visitors admire with awe are features that are quite typical for electric discharge actions with terminating primer fields. For example, the near-circular alcoves that we see carved out off the canyon walls are typical for high-mass electric effects, but are not at all typical for water current erosion. The Grand Canyon is also a terrace canyon that matches in shape the shape of focused plasma of the type that we see an example of in the Red Square Nebula. Once an electric field becomes dense enough to support the flow of electric currents along its path, a strongly focused discharge event occurs that would be similar in shape to the Red Square Nebula. Electric plasma streams are easily possible between the Sun and the Earth, and they would become focused and concentrated by primer fields at their terminal points. With the Sun being the storehouse of electric energy in the solar system, the interplanetary electric streams would be correspondingly large, and when being concentrated by the primer fields, would be strong enough to cut through rock, like a hot knife through butter, while the Earth turns beneath the focused energy streams, leaving a trail of cut-out canyons in the wake. In the same manner as astronomers in today's electrically weak environment see sunspots anomalies occurring when the planets become aligned with the Earth, whereby the planet's electric fields affect the sunspots on the Sun, larger electric currents can become initiated in the stronger times that become interplanetary lightning bolts. The phenomena that we see today in the modulated sunspots, as they rotate into the visual field of the Earth, are but faint shadows of the gigantic events that the same electric fields could easily initiate in the hot times in the past, when the galaxy was bristling with dense plasma flows. The resulting large events might have been rather common then. The long, electrically carved canyons are typically oriented in line with the rotation of the planet they are on, both here on Earth, where the Grand Canyon has been carved, and on Mars, where a much larger canyon has been carved that dwarfs the Arizona Grand Canyon into insignificance, but which, too, displays all the same features that are typical for electric discharge phenomena. The Great Canyon on Mars, the Valles Marineris, has been carved into the Martian surface as a formation that spreads out up to 200 kilometers wide in some places and cuts 23,000 feet deep. It is also much longer. It stretches across 4,000 kilometers of the Martian landscape. This vast dimension makes Valles Marineris 7 times wider than the Grand Canyon in Arizona, 4 times deeper, and 9 times longer. It would stretch from New York all the way to Los Angeles. And like on Earth, so on Mars, the Great Canyon is aligned essentially parallel with the equator for nearly all its length. Valles Marineris was evidently carved electrically. It may have started near the middle with big impacts flowing outwardly in 2-3 directions, then trailing off along its axis, while Mars rotated below the continuing electric actions of the primer fields, possibly for a few hours, which focused the massive incoming plasma connection onto the Martian surface. That Valles Marineris was not caused by water erosion, as is officially believed, is evident by the Lichtenberg shape of the branches that are leading from its main channels. Water erosion does not typically produce the type of branching pattern that we see, especially not in the middle between close parallel channels. The branching pattern that we see on Mars and in Arizona alike are large-scale replicas of the electric discharge patterns that we see experimentally preserved from a high-voltage discharge into a block of clear acrylic. But why are the Martian electric features so much larger than the comparable features on Earth? Mars is only half the size, with a mere 10% of the mass of the Earth. Shouldn't the Martian features be less massive too, instead of being many times larger? The solution to the paradox is hinted at by something that is invisible. It is found in the effective force of gravity on Mars. With Mars being a tiny planet of only 10.7% of the mass of the Earth, it generates a whopping 37% of comparable gravity. Since mass generates gravity, the comparative ratio of mass to gravity should be roughly 1:1, instead of being 1:3.7, as the measurements indicate. The high gravity ratio tells us that a lot of additional mass exists on Mars that is not included in the mass calculation respective to the planet's size. This additional mass evidently exists on Mars in the form of absorbed plasma. Plasma particles are typically 100,000 times smaller than an atom of comparable mass. With Mars having almost no atmosphere and almost no magnetic field to deflect the solar winds, the planet acts like a giant sponge, soaking up solar wind plasma. It thereby becomes a highly electrically charged planet, and, as the result, a perfect electric target. The resulting electric characteristics makes Mars a perfect place for studying the powerful effects of electric discharge phenomena. The extreme electric charge of Mars is evidently also the reason why Mars is peppered with evidence of extreme electric connection events, of which Valles Marineris is, once again, only a small example. A much larger electric event occurred when Hellas Basin was carved out of the Martian landscape, shown in dark blue, which by electric deposition produced the Tharsis bulge with the removed material. This truly gigantic event evidently wasn't caused by a meteorite impact, but by a much larger force, the electric force. Hellas Basin is a giant, deeply cut pit. It has been dug down into the ground more than 23,000 feet deep, spanning an area 2,300 kilometers wide. No kinetic impact of any type creates this hugely wide and deep kind of pit. The resulting area of 5.3 million square kilometers in size is equal to roughly 70% of the land area of Australia. All of this was excavated from the Martian landscape in a single event. Obviously, it wasn't caused by an asteroid impact. An event on this scale is typically caused by the much more powerful electric force in the form of an electric stress explosion. The event that created Hellas Basin appears to have lasted for about 10 minutes, to judge by the slightly oval shape of the pit. The removed material, of course, didn't vanish. It appears to have been redeposited nearby on the planet in a whirl of electrically charged deposition. The process of electric deposition is routinely used in a type of electric arc welding. In the steel construction and manufacturing industry, a type of welding has been developed by which the material from a welding electrode is deposited onto the weld joint. On Mars, the material that has been electrically removed from Hellas Basin had remained sufficiently electrically charged by the impacting process that it became attracted back onto the surface, where it likely formed the Tharsis bulge, shown in red, a bulge of material piled up to 7 kilometers high, which extends over a 5,000 kilometers wide area, an area bigger than the continental USA. In addition, some amazing volcanoes are located on the bulge. Mars features a surprising number of extremely large volcano-type mounds. If one considers that Mars is a tiny planet with only 1/10 of the mass of the Earth, it seems illogical that one should see volcanoes on Mars, much less such gigantic ones that dwarf the biggest volcanoes we have on Earth. The biggest of the Martian so-called volcanoes is Olympus Mons. Olympus Mons is truly gigantic. It stands up 26 kilometers tall above the surrounding plain. This adds up to a whopping 85,000 feet. It dwarfs in height the tallest mountain we have on Earth. The base of Olympus Mons is as wide as all of France. It is wider than the entire chain of the Hawaiian Islands. Hawaii's big volcano is barely noticeable in the comparison. It simply doesn't make any sense that one should see such an incomparably large volcano erupting on such a tiny planet. The paradox suggests that Olympus Mons isn't a volcano at all, but is merely a mound of debris caused by an electric stress explosion of a large meteorite on a collision course with Mars. An approaching meteorite, which typically carries a strong electric charge, would see a substantial electric field extending from Mars into space. Long before an asteroid or comet would impact, the extending electric field would carry with it an electric discharge current that would shock fracture an incoming meteorite into a cloud of sand, or perhaps even molten sand or glass. All the apparent volcanoes on Mars, therefore, appear to be of the deposition type category instead of being caused by volcanic eruptions. One of the smaller mounds, Oscraeus Mons, even shows a slight resemblance of Lichtenberg figures, suggesting that electric currents were involved in the forming of it. Another example of this type of deposition mound is Archaea Mons, that rises 9 kilometers above the Tharsis bulge. The base of the mound is roughly the size of Ireland. The enormous size of these mounds indicates to some degree the immense power that is brought to bear with the cosmic scale electric forces. The electric stress fracturing that turned an approaching asteroid into a cloud of sand before it hit the ground has likely occurred in just a few seconds. We are simply not used to be thinking in such large-scale terms for electric events. The reason may be that such events have never happened in our time. While we will likely see more asteroid impact mounds being formed, it is unlikely that we will see new craters being carved into the Martian landscape. Mars is peppered with a multitude of craters. These craters are officially regarded to be asteroid impact craters. Since asteroid objects tend to disintegrate before they impact, the craters that we see on Mars in abundance are evidently merely telltale evidence of electric connection events of the planet with the Sun. They are simply discharge craters of numerous types and sizes. The Martian landscape is full of these craters. Many are rather tiny craters, but they are typical for electrically carved phenomena. They are too round to be anything else. If they were impact craters, they would have been forged in long elongated shapes, depending on the impact angle. Meteorites rarely hit on a 90-degree angle to produce round craters. The electric touchdown craters, as one might call them, are typically rather small in size and bowl-shaped in form. Victoria Crater, for example, measures only 750 meters in diameter and 70 meters deep. It is one of the craters that had been visited by NASA's rover. Another visited crater is the crater Endurance. It is only 68 feet deep and 130 meters wide. The electric connection to the Sun that causes such a small crater would likely have been invisible. The event would have appeared on Mars like a big whirlwind rising. One of the larger craters is Gale Crater. It was chosen as the landing site for spacecraft Curiosity. It is a large crater. It extends 154 kilometers wide across the land and has been cut 18,000 feet deep. It is peculiar in that it has a mountain standing in the middle of it, reaching all the way up to the surrounding landscape. The crater with a mountain in the middle is far from being typical for impact craters, but not so in the field of electric plasma physics. Dense electric currents pinch into a bowl-type shape. When the currents become too dense, the bowl opens up at the center. At the boundary, magnetic ring structures cause the plasma currents to change direction and flow upwards. In the resulting crater, shaped by powerful primer fields, the center of the crater remains largely untouched. It is not unusual, therefore, that one sees mountains at the center of many of the craters on Mars. It is highly unusual, however, to see the craters to be any other shape than round. Thus, hopefully, the day will come soon when the realization takes hold that the craters on Mars are not caused by impact events, but by high-powered plasma currents connected with the Sun. General science is slow in recognizing the evidence for what it is, for the simple fact that we live in an epoch of extremely weak galactic electric density, which reflects itself onto the solar system. In the context of the very long sweep of the history of our planet, we live presently in a radically diminished electric environment. Two long eclectic cycles are known to have affected our galaxy by means of intergalactic resonances. One of the long cycles is the 140 million year cycle, and the other the 62 million year cycle. Both are presently at their low point. The conditions are so weak at the present time that the Sun itself will soon begin to flicker on and off in beats of 1,470 years, as it had evidently done during the last ice age. That had been a long night with a dark and cool sun cycling on and off at the beat of the Dansgaard-Oeschger oscillations. The very big events that have carved the giant canyons more than 20,000 feet deep into the ground won't likely be happening again for quite a few tens of millions of years, until the long galactic cycles move away from their combined minimum levels that presently determine the electric condition in the solar system, and with it the climate on Earth. When we visit the great monuments on Earth, we see in them a tiny bit of a history that once was, from times long before the dawn of man. We also see, as we look at the Sun, a few traces remaining of the interplanetary electric connections that we see evidence of in the dynamics of the sunspots. Soon we also see the Sun itself becoming inactive and dark as the next ice age begins. But even then, in the weakest of all times, the giant events give us a hint that there remains nevertheless enough energy in the cosmic electric system to satisfy all of our energy requirements from now to eternity. That the Earth remains a highly charged electric planet in spite of the extremely weak general electric environment of the type that occurred only once before in known history, some 450 million years ago, is evident in the Sahara Desert. The Sahara Desert is a contemporary monument of the power of the electric force on the planetary scale. It is the largest sand desert on Earth, and probably the youngest of them all. That the Sahara was once a lush region with rivers flowing and animal life in abundance has been extensively documented in rock art that is surrounded today only with sand. The sand appears to have been deposited by an electric stress explosion of a swarm of asteroids or comet fragments in contact with the Earth's atmosphere, possibly 8,000 years ago, or a bit sooner. Too much sand lies piled up in the Sahara for it to have been caused by short-term wind erosion of nearby mountains. Some of the dunes are piled up 600 feet high. And those are just surface features. The Sahara seems to tell us that we live on an extremely energy-rich electric planet, with resources that we haven't even begun to explore more than just superficially. Those are the resources that we will have to rely on in the near future for our energy needs, as our current energy reserves are being depleted, and the greatest transformation of our planet lies before us with the coming ice age, where the sun goes inactive, dim, and cold for long periods, which may begin in 30 years. In preparation for the transformation of our planet, for which we need to build vast new infrastructures for our food supply, the development of the cosmic energy resources would be a great help. In this context, the planet Mars, as it reveals its secret, is saying to us that we should move ahead and reach forward to the great future we can have, for which the resources already exist, including the human resources and cultural, technological, and economic power. The fact that we have been able to explore space, visit the moon, and learn the intimate secrets of distant planets, and explore our own world, in this context, proves that we are a profoundly capable species, the tallest form of life that we know to exist that has the capability developed, for the first time ever, to render the coming ice age, with a dimming sun, in 30 years, a non-event.